rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to Eschand Academy, the official YouTube channel of Eschand Publishing. The book here is Mathematics for IIT-JEE Main and Advanced by Emil Khanna sir, and I am Subuh Nadeem presenting you the videos of the concerned chapter here. So the chapter which we are doing is the chapter number 34, which is of the volume 2 of the book. It is probability, and then we have few important theories here to discuss as a revision. So what is probability of an event A? It is number of elements favoring that event by number of elements in the sample space if all the events are equally likely. Further, we have a formula that probability of union of two events, that either A occurs or B occurs, is probability of A plus probability of B minus probability of A intersection B, that is both occurs. So this is the addition rule of probability, which comes from the concept of sets from Venn diagram, and it is also called mutually inclusive and exclusive principle. Then we have conditional probability. The conditional probability says that if we have, suppose, an event B which has already occurred, then what is the probability that the event A will occur? That is P of A by B. So this is actually P of A intersection B by PB, where PB is not equal to 0. And further, if events are independent, like if the occurring of A and B are not dependent on each other, then we say that P of A by B is equal to P of A, and in such situation P of A intersection B comes out to be equal to PA into PB. So if the probability of occurrence of A does not depend upon the probability of occurrence of B, then we say that these are the independent events, and P of A intersection B is equal to PA into PB. Next we have is total probability theorem. The total probability theorem says that probability of an event E to occur is actually probability of A into probability of E by A plus probability of B into probability of E by B, and so on, where A, B are all mutually exclusive and exhaustive events. So what we mean by mutually exclusive? Mutually exclusive means that their intersection probability is 0. So if we say that two events are mutually exclusive, it means probability of A intersection B is equal to 0. And what do you mean by exhaustive? It means probability of A union B union so on is equal to 1. Now you can understand this by a diagram also, that if we have this as the sample space, this is an event A, this is an event B, both of these are mutually exclusive and exhaustive because there is no common here, so it is mutually exclusive, and we keep on making more events like this, and we say that they are exhaustive, they make the whole sample space. Now if we take an event E which is common to many of them, then this can be written as the probability of occurrence of E is equal to PA into PE by A, that is this portion, then PB into PE by B, this portion, PC has no common intersection, then PD and others. So we keep on writing like this. After that we have something called Bayes theorem. Bayes theorem says that if we have an event A and when B has occurred, you have to find the probability of A. Now here you can't find it by the formula P of A intersection by PB directly. So what you will do, you write it as P B by A into PA. Then in the denominator P B by A into PA plus P B by C into PC plus P B by D into PD, like this. This is the base theorem. You will see its application also. Then we have binomial distribution. Binomial distribution says that if there is a probability of success, which is P, and probability of failure, which is Q, then probability of getting R success out of n independent trials is actually NCR P to the power R Q to the power n minus R. So these are the some important results which we will see here in the questions which are upcoming, and we will see their application. A pair of fair dice is rolled together till a sum of either 5 or 7 is obtained. What is the chance that 5 comes before 7? So let us say when 5 will occur. 5 will occur if we get 1 comma 4, 2 comma 3, 3 comma 2, 4 comma 1, like this. 7, when 7 will occur, we get 1 comma 6, 2 comma 5, 3 comma 4, 4 comma 3, 5 comma 2, 6 comma 1, like this. So probability of 5 to occur, which is event A, is actually 4 by 36, 1 by 9. And probability of 7 to occur, probability of B, there are 6 elements. 6 by 36 is 1 by 6, like this. So this is A event, this is B event. Now what is the chance that 5 comes before 7? So 5 comes before 7, that is A occurs in the first chance, or if A does not occur in the first chance, then B also does not occur in the second chance, and A occur in the third chance. Or A does not occur in the first chance, B does not occur in the second chance, A does not occur in the third chance, B does not occur in the fourth chance, and A occur in the fifth chance. Like this it will go till infinity. So when you apply the probability formula, this will be PA. Since these are mutually exclusive events, you can write in addition. And since these are independent events, you can write them in multiplication, by multiplication theorem, like this. And this goes on. So what is PA? Probability of A to occur. It is 1 by 9. What is PA complement? That will be 8 by 9. What is PB complement? That will be 5 by 6. And what is PA? That will be equal to 1 by 9. Then again we have 8 by 9 square into 5 by 6 square into 1 by 9. And this goes on. So what is the chance that 5 comes before 7 is this. Now we have to calculate it. So when we calculate it, I am doing the calculation part here. So when we calculate it, this is a GP. 1 by 9 can be taken as common till infinity. So A is 1 now, by 1 minus R. R is 8 by 9 into 5 by 6. This is the common ratio. So this will become 3 and this will become 4. So 20 by 27. So 1 minus 20 by 27. This is what you will get here. So this will become 27 minus 27, 63, and 27 here. So 9, 3, 27, 9, 7, 63, 3 by 7 will be your answer. Let us move on to the next one. A man takes a step forward with probability 0.4 and backward with probability 0.6. Find the probability that at the end of 11 steps he is 1 step away from the starting point. So how is it possible? Either he has taken 6 forward steps and 5 backward steps, or he has taken 5 forward steps and 6 backward steps. So in one case he will 1 step ahead, in another case he will 1 step behind. So 1 step away will be 2 cases. Now if you take the probability that he is 1 step ahead, So for one step ahead, he has taken 6 forward steps. So we'll take out of 11 6, 11 C6. Now if he takes a step forward, this is probably 0.4. So it is 0.4 to the power 6. And backward is 0.6. So 0.6 to the power 5. If we are saying that he has taken one step backward, so one step backward would be 11C6 here also, which is backward, and it is 0.6 to the power 6 and 0.4 to the power 5. Now you will see that either this happens or this happens, and these are mutually exclusive. So answer could be addition of all both this. So 11C6 into 0.6 to the power 5 into 0.4 to the power 5 into 0.4 plus 0.6, which will be of course 1. So you will get 11C6 into 0.6 to the power 5 into 0.4 to the power 5. This will be your answer. Let us come to the next question of probability. Let us see on which theory that is. So it says a problem in mathematics is given to three students whose chance of solving it are respectively 1 by 2, 1 by 3 and 1 by 4. What is the probability that the problem will be solved? So you can say that what is the probability that problem is solved can also be written as complement of, that is 1 minus, problem is not solved. That is easier to find, because in solving case there are many cases that A could solve, B and C could not solve, A and B will solve, C will not solve, C will solve, A and B will not solve. Many cases will be there. So let us take probability of problem is solved is 1 minus probability problem is not solved. Here if problem is not solved and it is given that the students can solve it with the probability 1 by 2, 1 by 3, 1 by 4. So you can say that first one has not solved it, into second one has also not solved it, into third one has also not solved it, like this. So PA complement will be 1 by 2, 1 minus 1 by 2. PB complement is 1 minus 1 by 3, which is 2 by 3. PC complement will be 3 by 4, like this. So this will cancel, this will be cancelled, and 1 minus 1 by 4 is 3 by 4. So 3 by 4 is the probability that the problem is solved. So this is a easier and less time taking method here. Three players A, B and C toss a coin cyclically in that order, that ABC, 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 so on, till a head shows. Let P the probability that the coin shows a head. Let alpha, beta and gamma be respectively the probabilities that A, B and C gets the first head. Prove that beta is equal to 1 minus P alpha. Determine alpha, beta and gamma in terms of P. So this type of question we have dealt a while ago. What is happening over here is that first let us talk about alpha. Alpha is probability that A gets the first head. So if A gets the first head, the probability is P. If A does not get the head, then it is 1 minus P. Then B will also not get, then C will also not get. Then we will get after that. Again, if we keep on doing this, 1 minus P to the power 6 into P, you will get like this series till infinity. Now this first term is P by 1 minus R. Common ratio is 1 minus P cube. So 1 minus P cube, we will write it like this. Now if you talk about beta, so in beta B is having the first head. So A is not having the first head. Then B is having the first head. Or A is not having the first head, B is also not having the first head, C is also not having the first head, then A is also not having the first head, second head now, and that is not the first head, but B is having the first head. Like this it will go on. So this will be 1 minus P into P, this will be 1 minus P to the power 4 into P, then 1 minus P to the power 7 into P. So you will write 1 minus P into P as common, by 1 minus p whole cube. The common ratio is still 1 minus p whole cube. Similarly, if you come to gamma, you will see that 1 minus p whole square into p, that is c is having the first head, then 1 minus p to the power 5 into p, then 1 minus p to the power 8 into p, so on. So this will give you 1 minus p whole square p by 1 minus p whole cube. So this is the first thing that determine alpha, beta and gamma in terms of p. So we have got alpha, beta, gamma in terms of p. Now, if we say that beta is equal to 1 minus p into alpha, is it true? So beta is this and alpha is this. So yes, beta is equal to, if you multiply 1 minus p to alpha, to this alpha, you will get this beta. So this is also true. Let us come to the next question. The next question says, 3 of the 6 vertices of a regular hexagon are chosen at random. The probability that the triangle with 3 vertices is equilateral equal to. So there is a hexagon like this and we are choosing any 3 vertices of the 6 vertices. So total number of ways is 6c3. Though the number of favorable ways that the triangle with 3 vertices is equilateral. So two possibilities could be there. Either you take a triangle like, not like this. You should have a triangle for equilateral case, either like this, or you take the triangle like this. So two cases are there. So 2 is the favorable case. So 2 upon 6c3, which will be 6 into 5 into 4 by 6, that is 20. It is equal to 1 by 10. So you get C option, which is 1 by 10. Let us come to the next question. India plays 2 matches, each with West Indies and Australia. In any match, the probabilities of India getting points 0, 1 and 2 are 0 0.45, 0 0.05 and 0 0.50. These points respectively. Assuming that the outcomes are independent, the probability of India getting at least 7 points. So India is playing 2 matches, each with West Indies and Australia. So how many matches he is playing? India is playing 4 matches. Now 4 matches, 7 points can be accrued if he gets 2 points in 3 matches and 1 point in the 4th match, in that situation. So how is it possible? So this is possible, at least 7 points. So this is one case. Another case is that he gets 2 points in all the 4 matches. So two cases are there. Case number 1, case number 2 for at least 7 points. So for this case, number of ways is first to choose 4C3 number of ways, any 3 matches where India is getting 2 points. So if India is getting 2 points in 3 matches, what is its probability? 0.5. So 0.5 to the power 3. And of getting 1 point, the probability is 0.05. So 0.05 to the power 1. Similarly, for all the 4 matches, it will be 4C4 and 0.5 to the power 4. It will be. That is 2 points in all the 4 matches. This is 0.5 to the power 4. So when you will calculate, you will get 4C3 as 4 and 0.5 cube is 0.125 and into 0.05, 0.125 into 0.05. So this will become 5525, 2 carry, 1 carry and 5 places like this. So this will be 0.00625 into 4 you will do. So when you will do into 4, what you will get? 4, 5, 20, 2 carry, 4, 2, 8, 2 carry, 10, 1 carry, 4, 6, 24, 25, 0.025. This is what you are going to get. Here you will get 0.5 to the power 4 0.0625, right? Now, if you add both the cases, you will get 0.0875. So option B will be the correct option. So you have to add this one with this one and you will get the answer. Next question says, one of a pack of 52 cards has been lost from the remainder of the pack. Two cards are drawn and are found to be spades. Find the chance that the missing card is a spade. So it is saying that what is the chance that the missing card is a spade. So it is a question of Bayes theorem. Suppose missing card is a spade is one case which we have to see, and it is said that when you take two cards they are found to be a spade. So this diagram I am drawing here, we have started the experiment and we are saying what is the chance that missing card is a spade. So spade lost, this is what we are saying, and here we are saying a spade not lost. What is the probability of losing a spade? Since there are 13 spades out of 52 cards, so it is 1 by 4. And what is the probability of a spade not lost? It is 3 by 4. Now it is said that out of the pack, rest of the pack, two cards are drawn. So if you draw two cards and you say that a spade is lost, then out of 51, how many cards are there? A spade is out of 51, 12. So 12 C2 is the number of ways in which two spades can be taken, and 51 C2 is the total number of ways. And if it is said that a spade is not lost, so a spade is not lost, that probability is 13 C2 by 51 C2, like this. That is, out of 13, two cards are a spade, and out of 51 you are taking two cards. So if you calculate the answer would be, by Bayes theorem, missing card is a spade. So you will multiply this with this, 1 by 4 into 12 C2 by 51 C2 upon 1 by 4 into 12 C2 upon 51 C2 plus 3 by 4 into 13 C2 upon 51 C2, like this. So in the denominator we use total probability theorem in Bayes theorem, and we are doing that. This will be 12 C2, which will be equal to 12 into 11 by 2, that will be 66. And then we have 4 cancel, 51 C2 cancel, 12 C2 here also, 12 into 11 by 2, that will be 66. And 13 C2, if you calculate 13 into 12 by 2, that is 13 into 6. And 13 into 6 will be 78. 78 into 3. So 78 into 3 would be 8, 3, 24, 2 carry, 7, 7, 3, 21, 2, 23, 234. So you get 66 upon 234 plus 66. That will be 300. So you will get 6, 11, 66 and 6, 5, 30. That is 11 by 50 will be your answer here. So you have to quite cautious the cause and effect function here in Bayes theorem. The next question says, consider 5 independent Bernoulli's trials, each with probability of success P. If the probability of at least one failure is greater than or equal to 31 by 2, then P lies in the interval. Again, probability of at least one failure. So probability of at least one failure can be written as 1 minus probability of all success, that is no failure. So that will be 1 minus probability of all success. So 5 independent Bernoulli trials, each with probability of success 5. Now probability of all success. So 5C5, P is the probability of success to the power 5. And this value is greater than or equal to 31 by 32. So 1 minus P to the power 5 is greater than equal to 31 by 32. This will give you P to the power 5 less than equal to 1 by 32. So P is less than equal to 1 by 2. So you will say 0 to half, as probability will be greater than equal to 0 and less than equal to half. That is all for today's lecture, students. Thank you.